Okay, this is review 2.3. We're going to talk about our parent functions and transformations and graphs. For the first part, it wants us to identify which parent functions are odd and continuous, and we will check all that apply. Well, our linear functions are definitely odd, and they are continuous. Our cubic and cube root, and also our sine functions. Those are all odd. It would be a good idea to look over and see which one of these would also be even and continuous. That might be something good for us to know for the upcoming test. So make sure you look at those for sure. Okay, for the next part, we're going to use this graph. And for the first part, it wants us to identify what the parent function might have been. And here for our parent function, it looks like it would be x cubed for sure. Okay, and then let's look at some transformations. Remember, if it says horizontally, that's going to be on the inside of our function with our exponent on the outside. And notice it says by a factor of 1/3. So originally that was 3. And we only do that when we talk about our horizontal dilations. So for this one, we have the function f of x equals, and we are going to have a horizontal compressed by a factor of 1/3 reflected over the x-axis. So I know that negative is going to have to be on the outside. We're translated up 5 units. So we're going to have something that looks like this, and then plus 5. That should get us with all of those transformations. Okay, the next part, it wants us to describe this. Now, a good way to rewrite our function that we're given is to move that divided by 4. We can move that out to the side if you wanted to, and maybe that helps us see that this would be a vertical transformation. So writing this out, we have a vertical, and that is a compression because it is less than 1, the absolute value of it. So we have a vertical compression by 1/4. And then we also are reflected, since this is on the inside, we need to reflect over the y-axis. And then we also need to go to the right 2. And then we will go up 3. Okay, so for our next function, notice what all it does ask us for. And so for the first thing, we definitely need to identify the parent function, which is going to be f of x equals the square root of x. And then when we talk about our transformations, we have a vertical compression, and that is going to be by 1/2. We also have a movement to the left 1, and then we also move down 7. So from 0, 0, from that original point, we're going to go left 1 and then down 7. And notice again, this is not going to be reflected over any particular axis, so it's going to run something like this. There's our square root function. And now let's talk about our domain. And the domain for this looks like we're going to have all real numbers, but it's going to start here at -1. So we're going to say that the domain is going to be from -1 to infinity. Our range is going to be from -7 to infinity. Our y-intercept, in order to find that x and y-intercept, remember for the y or the x-intercept, That's where y is 0, and then we solve. So if we're going to do that, remember we're going to let f of x be 0 equals, and then we're going to have 1/2 times the square root of x plus 7, or x plus 1, then minus 7. We're going to add 7 over, and then you're going to want to multiply by this 2 and multiply that over. So I have 14 equals the square root of x plus 1. We need to square both sides, and if we square both sides, again, we are squaring 14. So that's going to be 196 equals x plus 1, so 195. That would be our x-intercept. So here, 195, comma 0. Our y-intercept, we're going to let x be 0, so that'll work out a little bit easier. F at 0, we're going to have the square 1/2 times the square root of 0 plus 1, and then minus 7. So that's going to be 1/2 times 1, then minus 7. So that's going to give us 6.5, negative 6.5. So here we have 0, comma, negative 6.5. Now, our extrema, that's talking about our relatives and our absolutes. And here we have, down here, way down here, we have an absolute min. And that's going to occur at -1, -7. And increasing intervals, we are increasing from -1 to infinity, and decreasing, we don't have any of those decreasing intervals. And for our end behavior, this one's really strange. Since this is going to end here, we really need to talk about the end behavior as x approaches positive infinity, that our function f of x is approaching positive infinity as well. As far as going back toward negative infinity, it's not, and I really would rather us not talk about here at -1, because we only have a one-sided limit going on there, and we don't know about that yet. Okay, for this one we have a parent function of the cube root of x. So here we're going to have f of x equals the cube root of x. And then our transformations, we're going to have a horizontal compression, as it is on the inside, by 1/4. We do the reciprocal if this is on the inside. We also see that we are reflected about the y-axis, and we have moved down 2. So we've got some interesting things going on here. So our parent function, that cube root function, always looks something like this. But we're going to take that nice point there, and we need to move that down 2. And then we need to reflect over the y-axis. So we have something looking like this now. It's kind of snaking around there. Now let's go see if we can't find a good, maybe some good points for us to anchor this with. That might help. So let's talk about our x and y intercepts. Let's find those right quick. So if we go through and find the x-intercept, we're going to let f of x be 0. We're going to have the cube root, -4x, and then minus 2. So that's going to give us 2 equals the cube root of -4x. And we need to cube both sides. So that's going to give us 8 equals -4x. So x is -2. So that tells me I was pretty close in sketching this. We're going to cross right here. Okay, and so now let's go look for the other, and the other intercept, we're going to let x be 0. And if we do that, then I have the cube root of 0, and then minus 2, and that's going to give us negative 2. So that's going to be this point here. So we've got some good points here that we can go ahead and connect this with. It's going to look something like this. There's our cube root. Okay, and now let's answer some of our questions over here. Our domain, that's going to be nice. That domain here is going to be all real numbers. It's continuous everywhere, and so is the range. And our x-intercept we just found earlier, that's going to be at negative 2, 0. And y-intercept is at 0, negative 2. And then as far as our extrema, we don't have one particular point that is the lowest or highest here. We're not looking, we don't have that over the entire domain. Increasing, none. And then decreasing, notice this is decreasing from negative infinity to positive infinity. And then our end behavior, remember you always start out with x approaching infinity and x approaching negative infinity because that's your x-axis. And now let's talk about what our function's doing at each end. Well, as we are approaching positive infinity, notice this graph is ever so slowly decreasing towards negative infinity. And then over on the other side, it is increasing toward positive infinity. Okay, for this one, we're picking out that parent function. And the parent function here looks like it is going to be that reciprocal function, 1 over x. And do keep in mind that means that we will have some kind of asymptote to work with. Our transformations, this looks like we have a vertical stretch by 3. We move to the right 5, and we also need to move down 1. Alright, so for this one, I would definitely start out the fact that we moved right 5. That's moving that asymptote, so go over 1, 2, 3, 4, 5, and definitely have that asymptote there. That is a huge part of this graph, and you can't get it right without having that asymptote there. So definitely need to draw that in. And now looking at this, we can try to pick out our x and y intercepts. So let's go ahead and let 0 equal 3 over x minus 5 minus 1. So I'm going to add that 1 over, so 1 equals 3 over x minus 5. And I'm going to multiply x minus 5 over to the other side. So I have x minus 5 equals 3. So x has to be 8. So I know I have here the intercept way over here at 8, 0. So there was 5, 6, 7, 8, 0 right there. Okay, so, and let's look at trying to find where x is 0 here. Well, if we plug that in, that's going to give me 3 over negative 5 minus 1. And so that's going to give me negative 3 over 5 minus 5 over 5. So negative 8 over 5. So that's a little bit past negative 1 here. So a little bit over, let's see, x is 0, so negative 1, a little bit below that. We're going to cross there. And so there's not much more left for this function. So let's go ahead and draw that in. It's reciprocal, so it's going to do something like that on one side, and then over here on the other side, going to do something like that. All right, and now let's go answer some of those questions. Our domain is going to be all real numbers, except x cannot be 5. That's where that asymptote is. And it also looks like this is flattening out here. Looks like we're also going to have some issues here at maybe a -1 there. So our range, it looks like it's going to be, well, let's call it all real numbers for the moment. The x-intercept, we saw that to be at 8, 0. The y-intercept, we saw that to be at about -1.5-ish, maybe a little over 1. Let's see, let's go ahead and call it, it was -8/5. We can leave that. Let's do that. And then our extrema, we don't have any here. Increasing interval. This is not going to have any increasing. This, because again, you're reading this from left to right. So you're actually decreasing from -infinity up to that asymptote, and then over on the other side of the asymptote to infinity. And our end behavior here, as x approaches positive infinity, and then x approaches negative infinity, and then set up your f of x. And as x is approaching infinity, f of x looks like it's probably approaching infinity. And let's see, over on the other side, same idea. So, oh, and this is approaching negative infinity, sorry. Alright, last problem. Here we are first going to have to go do some substitution. We've got to find f at -7, and that looks like we are going to substitute that into this top portion here. If we plug in -7 there, then that is going to give us -2 cubed -a, then +a, and then +4. So that is definitely going to give us 12. If we plug in -3, that's going to have to come in down at the middle one, and so that looks like that's going to be -7. And then finally, they are asking us to sketch this. So on the sketching, do remember we have to break this up. And so it looks like we're going to be broken up at 3. So we've got a nice little border there. And then we also, over here at 2, have that. And so looking at this on the other side, let's plug in our -3. And if we do that, then we're going to have 2 cubed 8. That's going to be -8, and then -4. So I have -3, -4, open circle. So go back 3, down 4, and have an open circle. And keep in mind, this is cubic. It is going to be reflected. We move left 5 and up 4. So left 5 and then up 4. So there's that point of inflection. And so here we see that this function is going to look something like this. Okay. Alright, so now let's go over and look between -3 and +2. Between -3 and +2, we're going to substitute in our -3. And when we do that, we're going to end up with -9 plus 2, so -7, so back -3, and then down 7. So there's one point, and it is closed. And now we need to go plug in our other point of 2. And when we plug in 2, it looks like we're going to get -2. And that will be an open circle. So we're going to go back or over 2 and then down 2, and that one is open. And then notice here with our transformation, this is flipped over and moved up 2. There's the vertex, and now we have our parabola. We can go ahead and connect those. And y'all please do a better job drawing than what I can do. Alright, and then the last one, we have a line. We do need to plug in 2. And if we plug in that 2 as our starting point, then that's going to give us -3. So over here at 2, we are down 3. And it is closed. And now we can just count off our slope. That slope is -1. So that means we can go down 1, right 1, down 1, right 1. And there's our final part. Now to talk about the domain. That domain is all real numbers. The range is also all real numbers. And then for your discontinuities, you have a couple of jumps in here. You have jumps at x equals -3 and x equals 2.